Dear 9th class students, here today we are discussing in the chapter number system. The topic is operations on real numbers. Facts related to operations on real numbers. Facts related to operations on real numbers. See here. The sum difference product the sum difference product quotient of any two rational numbers the sum difference product quotient of any two rational numbers is again a rational number. See, this is most important. If you add, if you subtract, if you multiply, if you divide any two rational numbers, you get again a rational number. Here, a small note you have to take. Only a small note you have to take separately, that if PQ belongs to Z, and Q is not equal to 0, we know that P by Q is a rational number. We know already this. So, the denominator should not be 0. I am making you a point as a note. Already we know when P and Q are integers and Q is not equal to 0, then P by Q is a rational number. Now, if you go for this quotient, coming to quotient property, suppose take this is one note. So take another note. Note number 2, this is note number 1. Suppose A is equal rational number 5 by 4 and you take B is equal rational number 0. Then if you go for division, A by B is equal 5 by 4 by 0, which is not defined. So, the quotient of any two rational numbers is again a rational number. The quotient of any two rational numbers is a rational number. This property is accepted only in one situation, that is when denominator is 0. So, if you take A is 5 by 4 and B is 0, then you observe that A by B, the division of two rational numbers is becoming an undefined number. So, the quotient of two rational numbers is a rational number is 100% correct. Only in one situation it is not correct, when the denominator is 0. So, you keep this in mind that okay, if denominator is 0, that will become undefined number. Okay. So, except in that case, in all other cases, the quotient of two rational numbers is a rational number. Understood? Now, see here, coming to irrational numbers, the sum of any two irrational numbers is an irrational number. The sum of any two irrational numbers is an irrational number. Like for example, root 2 plus root 3, root 5 minus root 8, root 3 plus root 7, etc. All are irrational numbers. So the sum of any two irrational numbers is an irrational number. This is an example. So sum means it is an algebraic sum, means it includes minus also. Sum means sum or difference. Algebraic sum. So the sum or difference of any two irrational numbers is an irrational number. Okay, like this you can see. So coming to next fact, the product of two irrational numbers, the product of two irrational numbers is either a rational number or an irrational number. See, the product of two irrational numbers, the product of two irrational numbers need not to be an irrational. The product of two irrational numbers may be a rational number or an irrational number. You cannot say it is always irrational number. See, for example, root 2 is an irrational number, root 8 is also an irrational number, and if you go for their product, you get root 16, which is equal to 4. It is a rational number. Please do understand this point. So here you have multiplied two irrational numbers. In return, the product is a rational number. Now take another example, root 3 into root 3. So you are multiplying two irrational numbers. It is root 9, it is 3. So the product is a rational number. Next, if you go for root 5 into root 3, root 5 is an irrational, root 3 is an irrational. The product is root 15, root 15 is an irrational. So like this, what you can understand is the product of two irrational numbers may be a rational number or an irrational number. Understood? Next, property 3 is, here instead of product we take quotient. The quotient of two irrational numbers is either a rational number or an irrational number. Here also the same thing you can see as in the case of product. The quotient of two irrational numbers is an irrational number or a rational number. So for this I will give some examples. For this fact I will give some examples. You see here, For example, root 25 is root 125. Root 125 is an irrational number and root 5 is an irrational number. Now you see, root 125 is root 25 into root 5 by root 5. This root 5 get cancelled, you get root 25, which is 5, and it is, this quotient is a rational number. Have you seen this? It is a rational number. So here the quotient of two irrational numbers, you got a rational number. Understood? You take another example. Okay. Root 32 is an irrational number. Okay. And root 2 is an irrational number. You take this quotient. Root 32 means root 16 into root 2 by root 2. Root 2 get cancelled. Root 16 is equal to 4. 4 is a rational number. See here, the quotient of two irrational numbers you are seeing in these two examples, it is a rational number. Now let us take two more examples. Example 3. See, root 3 is an irrational number, root 5 is an irrational number, then root 3 divided by root 5, you get root over 3 by 5, which is an irrational number. So here the quotient of two irrational numbers is again an irrational number. In the previous two examples, the quotient is a rational number. Now here it is an irrational number. Let us take the last example. Okay, one is 3 root 2 and another is say 5 root 3. So 3 root 2 is a rational number, 3 root 2 is an irrational number, 5 root 3 is an irrational number. Okay, then this quotient, if you see, this quotient is, okay, 3 root 2 means it is nothing but root over 18 by 5 root 3 means it is nothing but root over 75. So which is equal to root over 18 by 75. It is an irrational number. So, in the previous two examples, quotient is a rational number. In the present two examples, the quotient is an irrational number. So, here what you observed? The quotient of two irrational numbers may be a rational number or an irrational number. Next, now if you take the product between a rational and irrational, if you take the quotient between a rational and irrational, what happens? Let us see. So next fact is the product of a rational number and an irrational number the product of a rational number and an irrational number is always irrational number. The product of a rational number and an irrational number is always an irrational number. If you take the product between rational and irrational, you get always irrational only. For example, 2 into root 3, which is nothing but root 12. 3 into root 5, which is nothing but root 45. 5 into root 2, which is nothing but root 50. So these all are the product of a rational and irrational number. These are all are finally irrational numbers. So the product of a rational and irrational number is always irrational number. Similarly, the quotient of a rational and irrational number is also an irrational number only. Quotient of a rational and irrational number is again an irrational number. Understood? Now, representation of the real number root x on number line. So how to represent the real number root x on number line? That is our now present discussion point. So for this I am taking an example and I am going to explain. Represent root 2 on the number line. Represent root 2 on the number line. So for this what you have to take is, okay, you have to take a number line, okay. Say this number line is some L on the number line, okay. Take the whole numbers with the scale 1 centimeter is equal 1 unit. Like this, use. Please take the whole numbers. Now at the point 0, please take a perpendicular. Are you following? And on this perpendicular, you mark a point A with 1 unit distance. You mark a point A with 1 unit distance. Now, please join this A to 1. So now consider this is O. O stands for 0. Consider this is A. Consider this is B, C, like this. So say this is P. Are you following? So now the distance between O to A is 1 unit, A to B is 1 unit, B to C is 1 unit, C to D is 1 unit. With 1 unit distance, you are taking the points. So here this OA is equal AB is equal BC is equal CD is equal DE is equal EF is equal each is equal 1 unit. And O stands for 0. O stands for the number 0. Therefore, as you are maintaining one unit constant distance. So A stands for 1, the number 1, B stands for 2, C stands for the number 3, etc. For sake of convenience, I am taking like this. Now at O, draw a perpendicular OP such that OP is equal 1 unit. Are you following? So now triangle AOP is a right angle triangle. So triangle AOP is a right angle triangle. Therefore, applying Pythagoras theorem, you have AP square is equal OA square plus OP square. AP is unknown, OP is known by 1 and OA is known by 1. So 1 square plus 1 square, 1 plus 1 2, AP square is equal to 2. So AP is equal root 2. So you got AP is equal to root 2. Are you following? Now take O as center. Are you following? Take O as center, AP as radius. Okay, and draw an arc. Draw an arc on the number line which cuts the number line at some point Q, you say. Now here you see, take O as center and AP, which is equal root 2, as radius. Draw an arc which cuts the number line at some point Q. So we are taking O as center, this AP as radius, and we are taking, okay, an arc which cuts the number line at some point Q. Therefore OQ is equal here, are you following, root 2. Therefore Q is the point which represents the irrational number root 2. Understood? So this is how you represent an irrational number on the number line. Dear students, our next point of discussion is exponent radical sign, radical, and finally surd. See, we are going to discuss the various concepts: exponent, radical sign, radical, and surd. See, if A is greater than 0, okay, is a real number, such that a power 1 by n is equal nth root a. If a is greater than 0, it is a positive real number. If a is greater than 0, we are insisting it to be greater than 0. So if a is greater than 0 is a positive real number such that a power 1 by n is equal nth root a, then so hereafter a power 1 by n is nth root a. Are you following? Then n is known as exponent n is known as exponent and a is nth root a is the radical sign and a is known as radical. Okay, so n is exponent, this nth root a, this is a way of expressing the number using radical sign, and a is known as radical. Did you understand? So next we are going to discuss about surd. Surd means, I'll explain here. If a is greater than 0, is a positive rational number here, and n is positive integer. In the previous case also it is positive integer only. N is positive integer greater than 1. In the previous context also n has same limits. N is positive integer greater than 1. And if nth root a is not a rational number, nth root a is not a rational number, then nth root a is an irrational number and it is particularly said to be a surd. Here you have to understand the difference between irrational number and surd. All surds are irrational numbers only, but all irrational numbers need not to be surds. I'll give example, you please see, wait and see for a moment. So if a is greater than 0 is a positive rational number and n is a positive integer more than 1 and nth root a is not a rational number, then nth root a is said to be a surd of order n, said to be surd of order n. For example, cube root 5 is a surd of order 3. Fifth root 11 is a surd of order 5, etc. Here then what number that present, okay, that is said to be order. So cube root 5, it is a surd of order 3. Fifth root 11 is a surd of order 5, etc. Now every student should know the difference between surd and irrational number. Difference between surd and irrational number. See here, one important point is every third is irrational number. Every third is irrational number. But not vice versa. But not vice versa. That means, but every irrational number may not be a third. This is the most important point, a sensitive point that every student should understand. Every third is irrational number, but every irrational number may not be third. For example, pi is an irrational number. This is the ratio of the circumference to diameter of a circle. Pi is an irrational number. Root pi is also irrational number. But root pi is not a third. So you can catch some irrational numbers which are not thirds, but you cannot catch third which is not an irrational number. That is why this explanation and this example have become most important. Is it clear? Now, dear students, here now we are going to discuss how to rationalize the denominator. So, if the denominator is a third or an irrational number, in mathematics there is demand for rationalizing the denominator. So, what is the procedure? Here I will explain. See, suppose if you want to rationalize the if you want to rationalize the fractions like 5 by root 2, it is very simple. Okay, so I am explaining with an example. You see, suppose if you want to rationalize the denominator of 5 by root 2, it is very simple that you have to multiply and divide with root 2, which root 2 is a rationalizing factor of the root 2 itself. Root 2 is itself a rationalizing factor. So you have to multiply and divide with the rationalizing factor. So this is equal to 5 into root 2 by root 2 into root 2. This is equal to 5 into root 2 by root 2 into root 2 is 2. So like how the denominator is rationalized. Now, suppose if you want to rationalize 6 by root 3 minus root 2, this kind of fractions if you see, then you have to multiply and divide with its conjugate. Okay. So now the conjugate of root 3 minus root 2 is root 3 plus root 2. So this is equal to, you have to multiply and divide with its conjugate. So it is root 3 plus root 2 by root 3 plus root 2. So I multiplied and divided by the conjugate of root 3 minus root 2. The conjugate of root 3 minus root 2 is root 3 plus root 2. That's it, very simple. Then 6 into root 3 plus root 2 by root 3 minus root 2 into root 3 plus root 2. This is equal to 6 into root 3 plus root 2 by a minus b into a plus b, a square minus b square. is equal to 6 into root 3 plus root 2 by root 3 whole square is 3 minus root 2 whole square is 2. So this is equal to 6 into root 3 plus root 2 by 1. Like how our given fraction has been rationalized. Suppose one more example we take. Rationalize 5 plus root 2 by 3 plus root 7. Here rationalize means we have to rationalize the denominator only. Okay? Unless otherwise it is specified, rationalize means rationalizing the denominator. So the conjugate of 3 plus root 7 is 3 minus root 7. So you have to multiply and divide with 3 minus root 7. So 5 plus root 2 by 3 plus root 7 into 3 minus root 7 by 3 minus root 7. Are you following? So this is equal to 5 plus root 2 into 3 minus root 7 by 3 plus root 7 into 3 minus root 7. Now if you go for multiplication, 5 3s are 15 minus plus into minus minus 5 root 7 plus 3 root 2 plus into minus minus root 14 divided by a plus b into a minus b, a square minus b square. So which is 3 square minus root 7 whole square. Then we are going to last step. This is 15 minus 5 root 7 plus 3 root 2 minus root 14 by 3 square is 9, 9 minus root 7 square is 7. So 9 minus 7 is 2. So like how our denominator is rationalized. So it is very simple. So when you are about to rationalize the denominator, you have to multiply and divide with its conjugate.